Hi, welcome back. So in this video, we're going to be talking about what happens if substitution fails. So let's say we want to try to substitute in. And this time, instead of getting a nice number like we did up here, we get this weird thing. We either get infinity over infinity or 0 over 0. Now, this is a huge problem because we don't really know what these are. For example, what is 0 divided by 0? Well, I know in algebra, if I take 0 divided by any number, I should get 0. But if I take any number and divide it by 0, we should get something undefined. That's a really weird thing right there. But what if we take any number divided by itself? We should get 1. So if I take 0 divided by 0, we have all these different issues that will arrive. So we don't really like 0 over 0. And the same issue occurs for infinity over infinity. We'll talk about that one later on. But because we don't know what these are, we have a special name. These are called indeterminate form. Now, there are other forms we'll talk about later on, but the main ones are 0 over 0 or infinity over infinity. Now, there is a problem. We think this, but we don't ever write this on the AP. We don't write that. We have to think it. I'll show you a way to get around in just a few moments. Now, the first method we're going to talk about is the factor cancel. Again, might be a review for some of you. That's awesome. The factor cancel is when you look for a common factor on the numerator and the denominator. In Algebra 2 and Pre-Cal, we use the same method to determine the location of a whole in a rational function. Matter of fact, we call this is the definition of a whole. So if we look at the very first one, we want to find the limit as x is approaching 4 right here. Okay? So as the limit as x approaches 4, if I try plugging in 4, you're going to notice we get 0 on top and we get 0 on bottom. Now, when we get to L'Hopital's method, we're going to talk about a much more formal method for writing this. Right now, we just want to kind of get around. We can say equals 0 on top, 0 on bottom. But notice, did I write 0 as a fraction over 0? I did not. So we can't write it this way, but I can kind of get away with it that way. So what this is telling me is that these have a common factor. All this tells me is that there is a common factor at x equals 0. That's all that tells me. We have a common factor here. So they'll cancel out. In other words, a whole. Dear Liza, a whole. So I can factor the limit as x approaches 4. If I factor the top, I'm going to get x minus 4, x plus 3. I know it's going to be x minus 4. I can cheat because the bottom is x minus 4. They have to have that common factor there. Over x minus 4. Cancel, cancel. Now notice, this is really big. This is not a value. This is a limit. So I still have to identify it by writing out that limit every time. We have to. If you don't write out the limit, you're saying that the value exists. And that's really what this is telling us, that the value itself does not exist. That's what it means there. We can only approach it. And in Pre-Cal last year, you said that this was a whole. So this is a line with a hole in it. Sorry, pen went crazy. This is a line with a hole in it at x equals 4. So let's see here. I can solve, but now I can solve. Now it's just my substitution. If I plug in, I get 4 plus 3, which is 7. And there's my answer. Now notice, before I even tried doing the factor cancel method, I checked first. Check substitution first. It's the easiest. If it works out, it's nice for us. So my hint, you always want to check for substitution first. Always check substitution first. So try a couple here on your own here. We got a few moments. Okay. And pause if you need to. So for the first one, let's see here. If I try plugging in the 3, whoops, this is definitely a typo I did not catch. Okay. This is definitely a typo. That should be a 2, not a 3. Oops. And if you notice on the top, we get 0 now. And on bottom, we also get 0. So I can factor. Oh no, difference of cubes, right? So I'm going to factor the top. Notice I'm going to rewrite the limit again every time. I get x minus 2 over, now difference of cubes, you might recall. If we have a plus b cubed, we're going to get a minus b, a squared plus ab plus b squared. All right. So on bottom, this is going to become x minus 2, x squared plus 2x plus what is the cubed root of 8 is 2, becomes a 4 right there. And notice those 2's cancel, which is the x minus 2's cancel there. And rewrite my limit. As x goes to 2, we're left with 1 over x squared plus 2x plus 4. Plugging in the 2, we get 4 plus 4 plus 4, which is 1/12. There's our answer. Notice, I wrote out the limit. Okay, kind of a hint here. As long as there's an x, you write out that limit. Once you get rid of the x, you don't need the limit anymore. That's kind of the hint I normally give. For the next one, be very careful. We get 2 to the x. That's a weird one. So be careful. 2 to the 0 is 1 minus 1. So that's 0. And the bottom, we get 2 to the 0 again, which is still 1 minus 1, which is also 0. So this is my indeterminate form. So to solve this one, I do have to factor. And I can factor this one. If I look at the top, it stays the same. Now notice, I'm leaving my limit there. The top is going to stay 2 to the x minus 1. But the bottom is really a difference of squares. So difference of squares, a squared minus b squared, a plus b, a minus b. Where our a is just 2 to the x. So the top is 2 to the x minus 1. Here we get 2 to the x minus 1 and 2 to the x plus 1. And what cancels? Anytime you get 0 over 0, whoops, let me see here, undo that. Anytime you get 0 over 0, something will cancel, guaranteed. So I can write this as x minus x approaches 0, 1 over 2 to the x plus 1, which becomes 1 over 2 if we can sub in the 0 now. Okay. Notice, write out that limit every time. All right, the last one here for this video, let's take a look at number 4 here. If I plug in the 0, again I get 0, and the bottom I get 0. It's like a no face, like, oh no. Easy to factor. I can factor the bottom, and I'm going to do that. Notice, I'm showing my limit because I can't substitute in yet because I get this weird 0 over 0 thing, which is a no. So this becomes x on top. And on the bottom, if I factor out the x, I get x minus 1. X is canceled, which is good for us. And I can rewrite that, the limit as x approaches 0, 1 over x minus 1. Notice I rewrite it before I substitute in. And if I simplify this, we get negative 1 right there. So it's just 1 over negative 1. Very good. All right, go on to the next video, and we will take a look at 2 other algebraic methods for us. Okay, I'll see you then. Bye.